you there? How do we get the volume of the liquid displaced to also have the volume of the solid? Yes. Akosi, are you there? Hey, Zuvia, are you there? People are quiet too. Bridget, Araba, Ella. Zuvia, you are here. Talk. Stephanie, you are here.
Hello.
How do we get the volume of the liquid displaced to also have the volume of the solid? Okay, Yaba. Let us give the chance to Yaba to, since he's been answering questions on this. Yaba, go ahead. Okay, Anne, let's hear from you. Anne, go ahead. I'm listening.
Sir, please, I think we should find the abstract first because of the in weight of the body in air, and then we have the apparent weight of the body in water.
You see, it's true. And all that you are saying is true. We have the real. Okay, and nice contribution. Let me take over. Okay, let me take over. You see, we have the mass. And let me take over from here. We have the mass in air, which is 237. Mass in air, which is 237.5 grams. We have the mass in liquid, which is 12.5 grams. We also have the density of the liquid, rho of the liquid, which is 1.5. So 1.5 grams per cm cube. So this value should inform us what to do. Okay, let me draw your attention to one of the equations we saw that weight in air, abstract is equal to weight in air minus weight in liquid, which is also equal to weight of fluid displaced, which is density of the liquid times volume of the liquid times gravity. Please, do we recall?
Yes, please.
Good. Now, it means that these are weights. Weight in air, weight in liquid. But whatever the question gave us is actually masses. Okay, say a solid weighs 237.5 grams. The captioning is weight, but what you were given in reality are masses. So we can express this, okay, into weight. Okay, 1 kilogram mass is equal to a weight of what? 1 kilogram mass is equal to a weight of what?
0.01 Newton.
No, I mean 1 kilogram. 1 kilogram mass is equal to 10 Newton. Good. And so 1 gram mass will be equal to 0.01 Newton, as you said. So it means that if I have this as the mass in air, to change this to weight, let me do it here before. To change this to weight, I have to multiply this by 0.01. And that would give us, what is 237.5 times 0.01?
2.7. 375.
Okay. Then 12.5 gram to weight 0.01 Newton. That would also be
0.1.
0. Point, 0. Point. Oh, I'm listening.
0.125.
125 Newton. Good. So once we've converted these masses into weight, we can substitute 2.375 minus 0.125 would be equal to. Now, what's the density of the liquid? The density of the liquid is 1.5. But because we converted these masses into weight, it means we have to also convert the density, which is in gram per cm cube, to kilogram per meter cube. Please, are we fine?
Yes, please.
Good. So do that for me. 1.5 times 1.5 times 1,000. 1.5 times 1,000 will be 1,500. Okay, times the volume of liquid displaced, we don't know, and that's what we are looking for, times gravity, which is 10 meter per second squared. Please, are we fine? Are we fine here? Hello, are we okay? Hello.
Please, when are we supposed to use 9.8 as gravity?
As what?
Gravity.
Oh, you see, the value 10 meter per second is an approximated value. In actual value or sense, gravity is 9.812, a lot of values following it, but we usually either run it to 9.8 or to 10 meter per second squared. Okay, so it's what you use actually depends on what the question gives you, and usually when it is not given, you take gravity to be 10 meter per second squared. Are you fine?
Mr. Adrian.
Hello.
Mr. Adrian, please. The 1.5 gram per centimeter cube. You got 1,500 kilogram per meter cube, right?
Yes.
But say, please, how can you go 1,500?
Hey, my dear questioner, if you have density in gram per centimeter cube and you want to convert it to kilogram per meter cube, just multiply by 1,000. So the density of water is 1 gram per cm cube, which is also equal to 1,000 kilogram per meter cube. The density of aluminium is, I think, 2.75. It is equal to 2,700. So just multiply by 1,000 when you want to convert to kilogram per meter cube. Okay.
Okay.
All right. Please do the subtraction for me. 2.375, and some quickly do that. When you subtract this from this is equal to
2.25.
2.25. Good. It's equal to, this is 15,000 times VL. VL therefore will be equal to 2.25 divided by 15,000. And that will be equal to
1.5 times 10 raised to the power negative.
5.5.
1.5.
Okay, 1.5 times 10 to the power
Negative 4.
minus 4. What will be the unit? What will be the unit here? Hello, what will be
Meter
the meter cube?
Meter.
Okay. So once the body is totally immersed in the liquid, the volume of the liquid displaced is equal to the volume of the solid. And so calculate the density for me. Just make me proud. 1 minute. Okay. I'm sure you are true. Hello, I'm sure you are true.
Yes.
As many?
Yes.
Is it better
Yes.
now?
Yes. Yes.
Okay. What did you get as the density of the solid? Oh, please, this shouldn't take you more than 1 minute. Oh. Xavier, are you there?
Yes, please.
What did you get? Hey, Yaba, Yaba. Yaba is not here. So who is here? Okay, so this divided by 1.5 would give us 0.15833. Okay, so this times 10,000 would be 1, 2, 3, 4. So 1,583.3 kilogram per cubic meter is the density of the solid.
Please,
Class, are we up?
please, why is the mass of the solid equal to mass in air?
Oh, you see, the real weight or the real mass of the object, the real weight, real mass is what we always have or measure in air, not in fluid. Is that okay?
Yes,
The
please.
mass or the weight of the object in air is always the real mass or weight. Okay. So
Yes, please.
this becomes the density of the solid. How many of you got this right? How many of you? 4, 5. Okay. Thanks so much. Yes, that means we are really following. Can I claim this? Can I claim this one? Because I'm giving you an alternate. Nanelpia.
Sir, please, where's the decimal placed or you've removed it?
Oh, it's here. I moved it. I was multiplying by 10 to the power 4, so I moved it 4 times to the right. 1, 2, 3, 4. That's how come I have my answer as 1,583.3. Are you okay?
Okay, thank you. Yes, please.
All right. A second method to answering the same thing. So let me pick this information from you before we move to the second method. If the density of the solid is 1583.3 kilogram per meter cube, what will that be in gram per centimeter cube? What would the same density be in gram per centimeter cube?
1.583.
So 1.583.
3.
Yes. Gram per cm cube. How did you do it? How did you do it?
You divide it by 1,000.
So the clue is that if you want the density in gram per cm to divide by 1,000. If you want it in kilogram per meter cube, multiply by 1,000. Class, are you okay?
Yes,
Yes.
please.
Yes.
Good. So method 2. The second method is that, let's recall, in deriving formula for the upthrust. Akosi, are you there? Maybe she's not around. In deriving formula for the upthrust, we got weight in air minus weight in liquid is equal to density, volume times gravity. Then, if you recall, I also said that this weight can be mass in air times gravity minus mass in liquid times gravity is equal to rho vg. Then we factorize g out. Then what happened? Then what happened from here? We divided through, or
Yes.
we divided through by G. Then we have MA, mass in air minus mass in fluid or liquid, is equal to rho V, which is the mass of liquid displaced. What it means is that instead of expressing this in terms of weight, we can also express them in terms of masses. Use what we were given. Okay, so the mass in air is 237.5 minus mass in liquid 12.5.
Please, I do not understand.
Come again.
I don't get you.
Oh, Bridget, I don't know if you were with us yesterday.
No, I left earlier.
Oh, Bridget, make time to look at the video, okay?
Yes.
Okay. If you look
Yes.
at it and you still have some concerns, give me information offline and I'll answer to you. Okay.
Yes.
Okay. So this is equal to the density of the liquid 1.53. No, 1.5. Sorry, 1.5 gram per cm cube times the volume of the liquid displaced, which we are looking for. So without any conversion, you can quickly get a value for the volume of liquid displaced. And that will be equal to, please subtract it and give me your final answer. I guess this will be
225.
225 divided by 1.5. And that will give us the volume of the liquid displaced. What is 225 divided by 1.5?
150.
150. This is what unit must this be?
Cubic
Centimeter.
So cm cube. Are we okay? Therefore, the density of the solid, which is equal to the mass of solid divided by volume of solid. And once this is completely immersed, the volume of the liquid displaced is equal to the volume of the solid. So we have 237.y divided by 150. And what would that be?
1.5833.
Same as when we converted. So this is another way of doing the same thing. But this would have the density in gram per centimeter cube. All right. Any question? Any question? No question.
Please.
Mhm. Let's be snappy with our questions. Time.
Please, when asked to find the density of an object, is it
Mhm.
always that you have to use the kilogram per meter cube?
You see, no. That is why we looked at the two different possibilities. That's the reason why I did the first one with you and is doing this with you. Whichever way you take, it will take you to the same destination. Are you okay?
Yes, please.
Good. I'm sure by now it's obvious which way to go, but it depends on the information a question gives you. Okay. All right. The B part is that we have to find the fraction of the solid submerged in a liquid of density 1.19. Can I claim the side?
Yes, please.
Okay. I want us to think through the question and then understand it before we solve. Listen to the question. Calculate the fraction of the solid submerged in a liquid of density 1.19. Class, what does it mean? What does the question mean? Yes.
Please, can you say it again?
You see, this is the question. The question is right on the board. Calculate the fraction of the solid submerged in a liquid of density 1.19 gram per cm. Yaba, your hand is up. Let's hear from Yaba.
I think it means the solid is floating. And so part of the solid is in the water, and then the other part is like not fully in the water.
Yaba,
So we have to calculate the parts that enter the water.
it's within, okay, as against the what? So the part of the solid within as against. Yaba, I'm listening.
You said
You mean we have to determine the part of the solid within the water as against the what? Because it's about fraction. As against the total volume of the solid.
okay.
Are you okay? Amma, I don't know if you want to add something. Amma.
Oh no, sir. Please can continue.
Okay. So all that the question requires is that we find the fraction of the solid submerged in a liquid. You have listened to it well. You missed some parts. Yes, we are looking for the fraction of the solid submerged in a liquid, but this time in a different liquid. Okay, the density of the liquid of the new liquid, okay, is 1.19. Earlier, we were given liquid whose density was 1.5. So we are putting the same solid in another liquid of this density, but we want to see the fraction of the parts which will be submerged within the new liquid. Please, are we okay?
No, please.
Calculate the
No,
fraction
please.
calculate the fraction of the solid submerged in a liquid of density 1.19. Earlier, the same solid was in a liquid whose density is 1.5. Okay, so the density of the old liquid is greater than the density of the new liquid. Please, are we okay here? Are we okay here?
No, please.
Good. So if
Yes.
if silence, I think I'm getting feedback here. So if an object, the same object, is initially placed in a liquid whose density is 1.5. Now the same object is in a different liquid, another liquid whose density is less than the earlier. What happens? Okay, so this, before we solve the B part, let's look at flotation. Let's look at flotation.
Yes, what did you say?
Pardon?
Please, which word did you just say?
I said before we look at the B question, let's look at flotation. Flotation.
Okay.
Okay. So we'll hold on the B part. Let's understand what flotation is about. Lower hand. Who is lower hand? Your hand is up. Your lower hand is up. Go ahead. Or it's a mistake. All right. So I'm clearing everything. We'll come back to it. Flotation.
No, please.
Mhm. What is the condition for which an object would float on another? What must be the first condition for an object to float on another? I don't see. Let me retrieve these hands. Oh, the hands are gone. What's the condition for an object to float on another? Let me scroll down to call them. Okay, go ahead. Go ahead. The first person asks. Quickly, let's go. Yes, what's the condition?
The
The
density of
object must be less.
Okay. The second hand.
the density of the object should be smaller than the density of the fluid.
Okay. The third hand. The third hand is gone.
When the upthrust on the body is equal to, when the upthrust on the body is equal to the weight of the body.
Good. Awesome. Yes. So the first condition you learned in JHS. Okay. If you are a fan of cooking and wamo, when you pour oil, cooking oil in a saucepan, and then you add water, the observation is that the oil settles on the water, telling you that the cooking oil is less dense as compared to the density of the water. So if an object's density okay, is less than another, it will float on the other one. Okay, so the first condition is that for a body to float, one density, the density of one body must be less than the density of another. In this case, we are talking about floating in liquid. So the density of the body must be less than the density of the liquid. Okay. Liquid. Then another condition, the second condition is that either the weight, let's pick the weight of the body must be equal to the weight of fluid. Let's use liquid, but we shouldn't forget that fluid refers to both liquid and gaseous. So weight of the body must be equal to the weight of the liquid displaced. So when we look at the second condition, weight of objects must be equal to the weight of liquid displaced. Okay, and because weight of objects is given as mass of objects times gravity, and weight of liquid displaced is mass of liquid displaced times gravity, we can also deduce from this that for a body to float, the mass of the object must be equal to the mass of the liquid displaced. Class, are we okay?
No, please. Help
Yes.
I can't see.
So either you
No,
express,
please.
I'll go over. Either you express it in terms of weight or in terms of mass. Okay. Let me take the second condition again. The second condition is that for a body to float, the weight of the body must be equal to the weight of the liquid the body displaces. Okay, so if Mr. Abia is put in water medium or in a pool, it means that for me to float, okay, my weight must be equal to the weight of the liquid I displace or the attract acting on my body. Okay, so if that equality is not achieved, I can't float. That is what it means. I'm coming. So for a body to float, the weight of the body must balance the weight of the liquid that the same body displaces in the liquid. So
Please, I don't get it.
you get it, don't worry. Weight of body must be equal to the weight of liquid displaced. When you are put into water medium, okay, The moment you are dropped into it, you push away some volume of water, and the volume of water pushed away will be equal to your body volume, or that part of your body within the water or the well. Please, are you okay? And so what you are displacing is the volume of water, which is equal to your body volume. But when you measure, determine the weight of this displaced water, okay, it must be equal to your own weight before you can stay afloat. So if your weight is not equal to the weight of water you displace, it means you will sink. You can't float. That's what I'm saying. Already,
Okay, so Mr. Edia, please, I wanted to ask a question.